Good morning, all of you. This is K. Ishwan from CSC Data Science Department, third semester, from third semester, section B. Now, I am presenting the topic of deadlocks and recovery system in the operating systems. So, now we go through the introduction. Deadlock systems, distributed deadlock detection and recovery overview. Now, we are exploring the deadlock systems and the recovery overview in this presentation. First, introduction. A deadlock occurs when two or more processes are waiting indefinitely for resources held by each other, forming a circular chain of dependencies. In distributed systems, detecting such deadlocks is more complex due to lack of a global system state, asynchronous communication between nodes, and network latency and message delays. And effective deadlock handling mechanisms are vital for ensuring continuous system operation and preventing the resource starvation. Here, the deadlock will be occur when two or more processes are waiting indefinitely for resources held by each other and forming of a circular chain of dependencies. When in the distributed systems, detecting such deadlocks is more complex due to the lack of global system state and asynchronous communication between the nodes and network latency and message delays. In effective deadlock handling, mechanisms are vital for ensuring continuous system operation. Next, definition and causes of deadlock. So what is deadlock? A distributed deadlock is situation where processes running on different nodes are waiting for each other's resources and forming a global wait cycle. What are the causes in include? Mutual exclusion. Resources cannot be shared simultaneously. Hold and wait. A process holds one resource while waiting for another. No preemption. Here resources cannot be forcibly taken away. Next, circular wait. A closed chain of process exists, each waiting for the next. In distributed system, these issues are amplified due to the partial visibility and the internode communication delays. So, the main causes of the deadlock is mutual exclusion and hold and wait and no preemption and circular wait. These are the main causes of deadlock. Next, what are the characteristics in distributed systems? First, lack of global knowledge. Here, each node only has a partial information. Next, asynchronous communication. It here makes global coordination difficult. Dynamic resource allocation. It increases the detection complexity. Next, scalability. Detection methods just adapt to network size. These characteristics demand decentralized algorithms and efficient communication to ensure timely deadlock detection. These are the characteristics of distributed system. Next, what are the challenges in the detection and recovery? So we must be face the challenges in detection and recovery. So the identifying global wait for cycles from incomplete data and managing of the communication overhead during detection, ensuring the consistency across nodes, handling false positives and negatives, and designing fair and efficient recovery mechanisms and balancing the detection accuracy with performance is key to minimizing system overhead. Deadlock detection techniques. There are some techniques in the deadlock detection. First, two main approaches are exist. First one, centralized detection and distributed detection. In centralized detection, all nodes send resource information to a coordinator. The coordinator constructs a global weight for graph WFG, simple but may cause bottlenecks and single point failures. In distributed detection, each node maintains a local WFG. Nodes exchange information to detect global cycles collaboratively and improve scalability but increases the messaging complexity. These are the two techniques we are using in the deadlock detection. Next, centralized detection methods. Here, centralized detection consolidates resource allocation and process state information in one location for analysis. And while simpler to implement, it may become a bottleneck and single point in the failure in the large systems. Here, in centralized detection methods, first, while we simpler to implement, it may become a bottleneck and single point failure in the larger systems. Next, distributed detection algorithms. Here, distributed detection algorithms are leverage local information and internode communication to detect the cycles. They improve scalability and fault tolerance but require complex coordination and the messaging overhead. Here, distributed algorithms can leverage the local information and can be internode the communication to detect the cycles. Recovery strategies. Here, if we lost the data, we have to recover the overall data. So we have some of strategies like process termination and resource preemption and checkpoint and rollback. Deadlock recovery aims to restore system operation after detection. Key strategies are included in process termination. Here, about one or more process involved in the deadlock, simple but may lead to data loss. Resource preemption temporarily take resources away from same process, requires rollback or checkpointing to maintain consistency. Checkpoint and rollback restore the system to previously safe state, reduces the cascading terminations. Next, process termination techniques. Here process termination resolves the deadlocks by forcibly ending one or more processes involved. This is the most straightforward recovery method but can lead to loss of work and impact system stability if not managed carefully. Resource preemption methods. The second method is resource preemption. Here temporarily takes resources from process to break deadlocks. While it avoids loss, it can cause inconsistency and requires mechanisms to the rollback or reallocate resources safely. So it is second method of preemption. Next, coordinated recovery protocols. Here, coordinated recovery uses synchronized actions across nodes to restore system consistency. This strategy minimizes disruption by carefully selecting termination and preemption but demands complex coordination and communication. System design and performance. Scalability consideration. Effective deadlock systems must scale with the number of processes and nodes. Distributed detection and recovery approaches are preferred for scalability, designed to avoid bottlenecks and maintain performance in large dynamic environments. So there are some of considerations in the scalability that are designed to avoid the bottlenecks and maintain the performance in large dynamic environments. So effective deadlock system must scale with the number of processes and the nodes. Next, fault tolerance and reliability. Here, systems must handle partial failures and unreliable communication to maintain consistent deadlock management. Redundancy, timeout mechanisms, and fallback protocols ensure the system remains reliable under various failure scenarios. Implement redundancy and timeout mechanisms, use acknowledgement retransmission protocols for reliability, and employ backup coordinators to prevent single point failures. And these ensure deadlock management continues even under partial system failure. Next, optimization of detection and recovery costs. Here, how we optimize the detection and how we recover and how much it costs. Balancing the overhead of detection and recovery with system responsiveness is critical. But techniques include minimizing messages complexity, selective detection intervals, and adaptive strategies to reduce overall resource consumption. Here, by the balancing of the overhead of detection and recovery with the system responsiveness is very critical. So, by the using of techniques like include of minimizing messages complexity and selective of detection intervals and adaptive strategies to reduce, it can reduce the overall resource consumption. Conclusion. So, here we concluded that distributed deadlock detection and recovery systems are vital for resource management in complex environments, and by the choosing of appropriate detection methods and recovery strategies is key to maintaining system efficiency and reliability. A well-designed system balances scalability, fault tolerance, and operational cost to ensure both distributed operations. So here we concluded that distributed deadlock detection and recovery systems are very vital and essential for the resource management in the complex environments. By the choosing of appropriate detection method and recovery strategy, it is key to maintain the system efficiency. But without the direct detection method and recovery strategy, we did not maintain the system efficiency and reliability. Here, a well-designed system can balance the scalability and the fault tolerance and operational cost to ensure smooth distributed operations. When we take the well-designed system, it can balance the scalability as well as the fault tolerance and the operational cost to ensure the smooth distributed operations. So a well-designed system and the deadlock detection and the detection method and the recovery strategies. These are essential and vital for the resource management in the complex environments, and to balance the scalability. The deadlock detection is and recovery systems are very vital. So, thank you for giving us an opportunity to present the topic about deadlock detection and recovery system in the operating system subject. Thank you.